Hi, in this video I'll work out a couple of examples involving the Central Limit Theorem. We start with the following problem. It says, for a Cal State student, the average annual cost of books and supplies is $1,800. The standard deviation is $589. Assume that the annual cost of books is normally distributed. If a sample of 40 students is surveyed and asked to list how much they spent on books over the past year, compute the chance that the sample mean is between $1,500 and $2,000. So we know we are working with the distribution of sample mean. We have a sample over 30. It has a normal shape. The mean is 1,800. We're looking for the area between 1,500 and 2,000. One hint that helps us determine that we're working with the distribution of sample means is we are given a sample size, n equal to 40. Our next step is to convert the sample mean values to z-values. So we have to convert 1,500 to a z-value. Let's key that in a calculator. To do this, we have 1,500 minus 1,800. I'll use parentheses, so 1,500 minus 1,800 divided by, once again, we use parentheses for the denominator, 589 divided by the square root of 40. Close the parentheses. Oops, make sure you're outside of the radical, close the parentheses, select enter, negative 3.22. Let's compute the second z-value. What I'll do is I'll just select the formula and then edit it. So I'll go back in here. All you have to do is highlight the formula, press enter, and you can edit the formula to save a little time. We'll change x bar to 2,000 and we get 2.15. Our next step is to calculate the area. We could look up the two z-values in table E and then find the two areas, subtract smaller from larger to get 0.9836. If we have a TI-84 plus calculator, we can also just look up the area. We press second, pairs, select option 2. The lower value would be negative 3.22. The upper value is 2.15. Make sure the mean is 0, standard deviation is 1, and then click on paste or highlight paste, hit enter one more time, and we can round to 0.9836. Let's take a look at the second problem. It states during a peak migration period, monarch butterflies lay eggs on milkweed plants. At peak migration, the area of Pacific Grove, California has an average of 5 eggs per milkweed plant with a standard deviation of 2.8. Assume the number of eggs per milkweed plant is normally distributed. Compute the probability that for 20 milkweed plants, the average number of monarch butterfly eggs will be less than 4.5. So this is a distribution of sample means. The mean is 5, standard deviation 2.8, n is 20. It has a normal shape, and we want to determine if the sample mean is less than 4.5. Our next step is to compute the z-value. So we type that in. We have 4.5 minus 5 divided by, use parentheses, 2.8 divided by the square root of 20. Close the parentheses, select enter, and we round to 2 places. Thus, we round to negative 0.80. Now we would look up negative 0.80 in our table to get 0.2119. We can also use the calculator to compute the area. We click on second distribution, select option 2. We have to type in the lower value. Since it's an extreme value, it should be negative 10 to the 99th power. The upper value would be negative 0.8. Leave the mean as 0, standard deviation as 1. Highlight paste. Select enter and select enter one more time. And we get the answer 0.2119. Thanks for watching this video.